Hey guys, here's my final. It's got a lot. I've recorded this several times. I'm not going to make it in 2 minutes, but we're going to try and go over everything here. We'll start with some of the basic things that I have. Here's my register. Just got our 4 bits using the D flip-flops and the muxes to control whether or not they need to be written to or not. And then here's our register file, which has 8 of those placed on here. You pass in the data you want to write, which gets fed into all of them, and then the write flag that goes through a decoder on the right address to determine which one to write to, and then it reads from all of them. This is just some debugging here, and then it reads A and B. My ALU takes data A and B in. It performs all the operations on them, so we have XOR, AND, OR, add, and not, and then the hardware subtraction. The add and the subtraction are using my adder, which we'll go to next, and they all get fed back out through this mux. This is also where I implement my jumps logic. Here's my adder. That's pretty basic to handle the carry, the sum, and then the carry out. I have a little program selector just so I didn't have to load different programs into it. I implemented a stack, in which case you can push things into and then pop them back out for function programming. And then here's my counter I implemented because I couldn't get the jumps to work right with the other counter. So it's got 8 bits, increment, decrement, gets fed back into it on the clock. So let's demonstrate really quick a hello world. Great, so that works. And then here's the program, that's the one we're actually supposed to do. So you see it's doing its arithmetic. Software subtraction, hardware subtraction, booyah. So just to be very specific, my hardware subtraction was done using my adders. I made a ones complement of the second number and fed a 1 in for the carry, which is like adding 1 to it, and then just added them all together. It's actually really cool that it works out that way. My software subtraction is implemented thusly. You load the data, you invert it using the not that I've implemented. You're going to load a 1 to add it into your inverted number and make it a 2's complement. Then you add the 2 together, and you can load the 3 to display our ASCII character out. Yep. There's a lot to my program. I'll post this with it so it makes more sense with the stack and stuff. But thanks for your time. Have a good day.